Hello, welcome everyone. My name is Hector. I am a field engineer at Unity based in Singapore, and I will be guiding you on today's webinar. Thank you for taking the time to be online for this. By the way, this is the first of a new series of webinars for the year 2022. Okay, so today we're going to go over a brief introduction of our company, explain the meaning of real-time 3D in applications, and show you how many industries are innovating by taking advantage of Unity and new products that we created for them. Finally, I will guide you on how you can get the Unity editor itself and start creating your own applications. In 2004, 3 colleagues founded Unity. Joachim, Nicholas, and David started a game company with the idea of making video games. After releasing their first game, Google, that you see here on screen, which by the way wasn't commercially successful, they realized that the tools and technologies that they had created to build their own game could benefit other creators. So in a time where only big companies were able to afford to license other game engines, in 2005, the first version of Unity was released. The goal was to create an affordable game engine with professional tools for amateur game developers in order to democratize the game development industry. Recently, developers are beginning to realize that game engines can be successfully used for non-game applications. For example, architects can easily prototype ideas. Artists can create interactive art installations, or researchers can use them for data visualization. And today, Unity is the world's leading platform for creating and operating interactive real-time 3D content. Our platform provides a comprehensive set of software solutions to create and operate content for mobile phones, tablets, PCs, consoles, augmented and virtual reality devices. At Unity, we believe the world is a better place with more creators in it. This philosophy is centered around serving creators, and it's the beating heart of our company. It motivates each and every one of us to help solve the toughest engineering, data, and operational problems so that digital creators such as yourselves can create and operate freely without limitations. First, it's important to realize how much the world is changing. What started in gaming has exploded. 5 years ago, we saw industries just scratching the surface of what was possible using real-time 3D. Specifically, we saw that many industries were still tied to creation tools that were conceived and built in the 90s and early 2000s, before the explosive growth of compute power in the personal devices that we now all carry in our pockets, as well as in the networks of computers that live in the cloud, adding even more processing capability. And because of this, users' demands are changing. The demand for highly interactive next-generation lifelike visuals is higher than ever. Creativity and technology are converging, spawning unlimited opportunities in every industry imaginable. This is where real-time 3D, or RT3D, comes in. So, here's how we think about it. Video games are among the most technically challenging forms of media to create, from a technical and engineering standpoint. They are complicated to build. Games are mostly 3D. They are real-time and they are interactive. 3D means that, unlike in a movie, a character or object is fully 3D, meaning that we not only see the front of the character, but we can move around and view the character from different perspectives. Real-time means that the next frame a player sees is created in an instant. In other media like TV or the web, most content is fixed and is not changing. Interactive means that games change in response to the input of the players. The content has to be dynamic and responsive, and Unity is leading the platform for creating and operating this type of media. Here's an example. So this first image you see here is a 2D pre-render image. It's flat, static, and it doesn't move. If a creator wants to change the contents of this image, they have to go back and load it in their creative tool and start the process of recreating the image. Real-time 3D is different, in that it transforms the composition of the pixels on a digital display multiple times per second. The result of this transformation has the illusion of being three-dimensional, with freedom of point of view in and around the entire image. Historically, this has been the domain of games. Where a player moves left or right, the image on screen is redrawn as fast as the player can see. So, this is what we mean by real-time 3D. So, how does the power of real-time 3D translates into creating and operating some of the best content in the world? Well, Unity is a comprehensive real-time 3D platform that gives anyone with access to a computer the tools and technology to create and operate any solution in order for anyone to be successful in the real world. With Unity Runtime Engine being the connective tissue that brings the platform together. As you can see in this slide, we can group creation tools such as the Unity editor, which is the main focus of today's presentation. But also there's new verticals such as Reflect, which was developed for the construction industry, and Forma, which is a marketing tool originally conceived for the automotive industry that leverages the power of high-definition real-time 3D graphics, letting users visualize and customize products all in one place. Also, we have a set of cloud services that allows you to operate your application. These are all powered by Unity, which means that they easily integrate with your applications and range from multi-user support, dynamic content delivery, user engagement, and tools for growing revenue in mobile games. The core of being able to create with Unity starts with our editor. We prepared a video to show you how different industries are using Unity to improve their own workflows. Let's have a look.
In Unity, you can do anything.
In Unity, I can choose who I want to be.
With Unity, I can have a small-sized team, but deliver on AAA quality.
It's pretty groundbreaking, let's just put it that way.
Whether or not that's film, or games, construction, or automotive, this creative medium is available to everyone.
So, what's the real-time engine? In factual terms, it is a piece of software, but it's so much more than that.
Unity's real-time 3D is an environment built to build video games, but these other industries are getting on board.
What Unity provides is a way that people from different disciplines communicate. Designers and artists and coders collaborate on the design together.
Unity is the bridge. That's how I see it.
In game development, it solves a lot of problems so you don't have to.
It's not just an editor engine company. It's giving the developers the tools to get our games in front of as many people around the globe as possible and make something that's really, really successful.
What is unique about Unity is we want to help developers build long-term relationship with players and generate revenue. Our vision is building successful businesses for our creators.
Whether you're one person, an indie developer,
Or you're part of a large team where you have 100 different peers working on one Unity game, you're all being powered by the same technology.
giving you this extra boost, this extra leg up to make our lives easier, but also to make the game better.
Unity is drastically changing the automotive industry. Using Unity as a glue, we can cover the whole life cycle of production processes.
Design, ergonomics, safety.
Machine learning training. Hey, can we actually test how rain will look and the wipers performance? Add the moose in front of the car and see how it will react. And everything was super fast because we were running Unity from the back seats.
In the construction field, we use Unity for everything and then some.
With augmented reality, we can overlay the entire building in front of the developer. We can feel that space with this dynamic environment that we can walk through. Select your wood grain, oak versus cherry, add lighting.
Our team can update the site, the project, the model instantaneously.
We can change how
we built all the tools of cinematography, staging and blocking and lighting and performance, and we built them into virtual reality. There's nothing that could get in the way of the filmmaker's desire to just work in real time, to work from instinct.
Interactive animation has to be immediate for you to truly believe it's real. And that's why we've used Unity for that.
This is the moment.
This is the future of animation.
Architecture.
The automotive industry.
Game development.
The next great filmmaker is a child who has these tools in their hands.
Even if you're one person, if you've got a great idea, you now have the technology to realize that.
Creators are the pace setters, the dreamers, those with an imagination, and we are here to support them because we think the world's a fundamentally better place with more creators in it.
I hope you liked that video. I think it's very inspiring. The idea that creators from many industries are joining us to improve their workflows and help their customers. I come from the games industry, and as we've said, Unity is a company born from gaming. Our Create tools are responsible for some of the world's most popular games. In Q4, games made with Unity included top-selling titles such as Among Us, Cube Surfer, Scribble Writer, Magic Tiles 3. And we are proud to say that games made with Unity accounted for 71% of the top 1,000 mobile games in Q4 in 2020. We also work closely with developers to bring their creations to life on Nintendo Switch. To date, over half of the Switch titles are made with Unity, including titles such as Kingdom Hearts, Ori and the Will of the Wisps, Genshin Impact, which is out on PC and other consoles, will be soon released on Nintendo Switch. But as we know, real-time 3D tools have applications outside of gaming, and our efforts beyond gaming are also gaining momentum. Our customers are turning to Unity to help them create and build everything in real-time 3D, from the next generation office buildings to self-driving cars to the video games enjoyed by millions of people around the world. In Q4, we began relationships with Newell Brands, Walgreens, and Liberté Productions, working for Show Studio and Nick Knight. Even marketing professionals across any industry now have a dedicated creation tool within Unity. Unity Forma is a product for digital marketing production that empowers marketing professionals to easily create and publish content and interactive experiences from 3D engineering data. Using Unity Forma, marketing teams can significantly reduce production timelines and costs, dedicating more time to the creative process to inspire shoppers and convert them into buyers. An example, in December 2020, we highlighted Volkswagen's innovative use of our vertical application Unity Forma to build an engaging virtual e-commerce showroom, to allow people to get an experience of seeing the new cars without being physically there. And for our industrial clients, we have Unity Reflect. We introduced Unity Reflect in 2019, and in Q4 2020, we extended its functionality to ingest files from Autodesk BIM 360, so that construction engineers can access augmented reality and virtual reality functionality on-site on their devices, tablets, laptops, or even their smartphones. Unity Reflect helps win more projects, conduct immersive reviews, and connect design with construction, all with our BIM coordination software. Users can bring multiple BIM models with all the metadata to real-time 3D and maintain a live link between them. Unity Reflect keeps everyone on the same page. With Unity, customers build an application once, and that application works seamlessly on more than 20 platforms. Instead of mastering and porting their content to additional platforms, developers can focus on creating great content with multiple paths to success. So, traditionally, coming from the games industry, this would be a list of all the different types of consoles. But also, there's also augmented reality platforms such as HoloLens, Magic Leap, and virtual reality headset that are being part of the supported target platforms. So for the rest of the webinar, I will be giving you a tour of the Unity editor and explain how you can get started using Unity. So we're going to go through some of these elements. I'm going to give you a tour of the editor, walk you through some of the key concepts, show you how to create a bit of interactivity, and show you how you can learn and start your Unity journey. And finally, we're going to have some time for Q&A. So let's get Unity. You can download Unity from our website by navigating to unity.com. First, you have to sign up for an account, and there's going to be an onboarding process that will walk you through the steps to start. Then, no matter who you are, there is a perfect plan for you. If you are a student or hobbyist, Unity is free for you to try. And if you're a small studio that's just starting to adapt Unity, Plus is a plan for you. Professionals and enterprise users can also get in on the action. Please feel free to reach out to the Unity team to ask any questions if you have any doubts. Whichever plan works best for you, keep in mind that all plans are royalty-free. You keep what you earn. And all plans include access to the Unity Asset Store and Unity Learn. The Unity Asset Store is a marketplace of assets for your projects, with sample projects and 3D graphics and meshes and animations and plugins that you can include in your project, some of them created by Unity, and most of them are created by third-party developers that create middleware to enhance your application. And the Unity Learn portal gives you official tutorials and guides you through your learning process, so you can support your team's expertise at every level. So after setting up your account, the first thing you will be prompted to do is to download the Unity Hub. The Unity Hub is a tool to help you organize your Unity editors and a great platform to learn the ins and outs of Unity. Because we are a technology company, Unity is constantly innovating. We release 2 major updates every year, along with a long-term support version for each major yearly release. In between, there are numerous patches, fixes that you can download to help you build the best version of your application. And also, if you are curious and want to see what is the latest, you can opt into the beta builds, where you can see some of the experimental features that are being developed. So, next step is when you press on the Install Editor button, you will be shown a list of Unity releases that you can download. You should always go for the recommended release that you can find listed here. Recommended version. Back in the Projects tab, click on New Project button. You will be asked to choose a version of Unity. There is a drop-down that you can select the version from, and also you can select one of these templates as a starting point. We have a range of templates you can choose from to kickstart your application, from 2D to 3D, mobile, AR, VR, and there's even a Lego microgame. These templates are fundamentally the same underneath, but are set up with important packages and assets that you would normally use for each respective platform or genre. So this means that if you know what you're doing, you can essentially migrate from one to another easily by just enabling and disabling modules and assets in your project. A quick note on render pipelines. When using the built-in renderer, the main camera in Unity renders its view to the screen. By using Unity's Scriptable Render Pipeline, or SRP, you can control the rendering process. URP is a pre-built scriptable render pipeline template that is quick and easy to customize, and lets you create optimized graphics across a wide range of platforms. URP also includes an optimized 2D renderer, complete with 2D lights and pixel-perfect rendering. And it has an integrated post-processing solution. High-definition render pipeline makes a good starting point for people focused on high-end graphics that want to develop games or applications for platforms that support shader Model 5, like high-end computers and next-generation consoles. It's worth noting that these templates are supported as a download via Package Manager, and URP is planned to replace the built-in renderer in the future. So URP is usually a good choice if you're starting a new project and want to benefit from better performance compared to the built-in renderer, and the ability to use materials created with Shader Graph, which is a visual node-based editor to create shaders within Unity. Now let's move on to the Unity editor. These are some of the basic elements that you need to know in order to find your way around the editor. We're going to discuss things like layout, scene view, hierarchy, game view, project, inspector, and then I'm going to show you how to navigate in the scene and some of the tools available to move objects around. So this is what it looks like. This is what the Unity editor looks like on Windows platform, which is what I'm running on right now, but we have it available also on Mac and Linux. So let's move to the editor on my computer. So this is the Unity editor running on my computer. What you can see here is that there is a different panels: hierarchy, scene, inspector, project. These are all the main elements of the Unity editor, and I'm going to explain to you what these are one by one. The first thing that you want to know is the project window. The project window is where you put in all your assets that you're going to bring into your project. For example, sound files, 3D models, animations, graphics. Anything that you want to use in your project will be added here, and by dropping it in this area, Unity will import the assets and convert them behind the scenes for you into the optimized format that is required for real-time 3D for whatever is the target platform that you have selected. And this one is similar to the file system that you can find in Windows, being Explorer, or on Mac, the Finder. This is like navigating folders in your project. There's also the hierarchy window. The hierarchy window shows a tree-like view of all the elements in your scene. And you can see that the first element is the scene called sample scene, and I can expand it and I will see all these elements inside. These elements are called game objects, and I can also click on them and select them. What you will notice is that when I select, for example, this one called main camera, or the one called directional light, they become selected in the scene view, and I can visually see what are the objects that are represented on this list. So another thing that you will notice that is happening is that when I select main camera, on the right side the inspector window changes and shows me the main camera object being selected, and then there is a list of components. These are all the components that are attached to this game object. The main camera game object has a transform component that defines the position, rotation, and scale of this object in the scene. A camera component that defines it, gives the ability for this game object to behave as a camera. We need a camera in order to render the graphics. Audio listener is a component that acts as a microphone, if you will. And there are some other scripts attached to this camera. And there's also a directional light. If I click on the directional light, you can see that it becomes selected. And now the inspector shows me the name of the directional light that we can change, for example, to the sun. And there is a transform component, because also this game object has a position, a rotation, and a scale. And it has a light component attached to this game object that defines that this is going to act as a light source for our scene. That's it for the different types of elements. Oh yes, finally I want to show you about the layouts. So the same way that you can configure most applications, you can also change the size of the different applications to suit your comfort. But you can also move them around. You can grab the windows and drag them and dock them to different positions. So for example, if I want to have the hierarchy closer to my inspector, this is the way I can do it. The sun, I see it selected in the scene view, I see it selected in the hierarchy, I see all the properties for the components displayed on the inspector. So this is convenient. Another thing I can do is I grab this project and dock it below the hierarchy, and maybe have this window and make it smaller. And there's also a game view. The game view, I can dock it to the bottom of the screen. This is what the main camera can see. So you can see that the camera is over there. It shows me a preview, but in the game view, I can also see what the camera will be rendered. And if we build an application, this is what the screen on the target device, for example, on a mobile phone, will be displaying. And the scene view is sort of like a behind the scenes where you can set up all the elements that you want to be part of your application, and even drive the camera. For example, to get a first person mode perspective, or you can have a camera follow a character to get an experience that is a third person style application. Interesting is that once you find a configuration of a layout that you like, you can go to this area, top right of the screen, and there is a default drop down here. It's actually showing that is the default layout configuration. But if you want, you can select different options like 2x3, and you see how it's changing. 4 split, default configuration, tall or wide, or you can come up with any configuration that you prefer and save it as one of add it to the list here. So the next time you come back, you can select it and get the best experience that everything is where you want it. And going back to the default space, there's also one thing that you can do is right click on the tabs and you can close the tabs. So if you close the tabs, I close the scene tab and I close the game tab, I can start modifying the inspector to a point that is very minimalistic. But I can also bring it back by selecting default, and all the windows will come back up. And one thing that not a lot of people know is that you can have multiple windows of the same type. So I can have a second inspector window, add tab, inspector, and dock it below. So I can have 2 inspector windows. This is useful in some cases where you want to watch some properties of a particular inspector of a particular object that is not selected. You do this by selecting the object that you want on the hierarchy, for example the sun, and you see how both inspectors show the sun properties. But then when I click on the camera, again, both inspectors show the camera properties. So if I want to always see the sun properties here, what I can do is I can click on the sun, and then there's this little lock button. I can click on this lock button, and now when I click back on the camera, only the top inspector that is not locked will show the properties and the components of the selected object. But the one I have below here will always show the properties for the sun. So this is helpful in some situations. And again, you can right click, close tab, or there's also a shortcut where you can middle click and it will close the window. Okay, next tab is scene navigation. Scene navigation is now that you know how you can move the layout of your editor, you can make this slightly bigger. There's also a shortcut to maximize it. You can find it here. Maximize to get temporary most use of your screen if you need to get more access, and you can uncheck the maximize checkbox to minimize it back. In order to navigate around the screen, there's the following tools. Okay, the first tool that you can use is the orbit tool, which you can engage by holding on to the Alt key, and you will see the pointer changing from the arrow to an eye icon. Let me zoom in so you can see it. This is what it looks like. And when you hold on the Alt key, you can left mouse click and drag left and right, and you will see that we are orbiting left and right. So this is very useful to get a different point of view of your scene. You can go behind the wall here where the light is to get a better look, and back to the front. And you can also go underneath or on top to get a top-down view if you want to have a better perspective to do object placement, for example. Then the next thing you can do is zoom in and out. So this is the same thing as we did just now, the Alt key down, and instead of using the left mouse button, you're going to use the right mouse button. And when you do that, you see the icon changes to a magnifying glass. That's to signify the zoom functionality. And now you can move the mouse left and right, and you're zooming in and out. And you can drag multiple times to get closer and closer and closer, or keep moving the mouse all the way to the side. And you're going to be moving in and out of the scene. So you can combine this by orbiting, zooming in, out, orbiting, zooming in, out to navigate on the scene. And finally, the other thing that you can do to navigate in the scene is use the hand tool. The hand tool you engage by holding on to the middle mouse button on your mouse, and you're going to get a hand tool, and this allows you to pan around the plane from the point of view of this scene camera. So if I'm looking at it from this side, it's going to allow me to pan around left and right relative to this point of view. Or if I go behind the wall and middle click, you get the hand icon, I can move up and down. So by combining these three tools, I can orbit, pan, orbit, zoom, orbit, pan around, and orbit, and basically find my way around the scene and get anywhere I want to get a better look at the objects that are placed in the 3D space. Additionally, you can use the mouse wheel to zoom in and out, but you see that it's based on steps and it's not very very accurate. So if you want to get in between or get more granular positioning, you should use this tool, the shortcut Alt and right click on the mouse button, and that's how you can move around. So once you master these tools, like left click, middle click, right click, these are all the tools, all the different buttons in the mouse allows you to navigate around your scene easily. And finally, I want to teach you the tools that we use to move objects around. So all the tools that we can use to move the objects around the scene are in the top left corner of the screen, right here. So the first one is called the Move tool. The second one is called Rotate tool, and the last one is Scale tool. And this will modify the corresponding properties of the transform component of any game object: the position, rotation, and scale. So for example, if I select the camera, I can see on the inspector that these are the properties for position, rotation, and scale. I can change the values by typing here new values. Instead of 2.3, I can type 3, and I can see the camera moving, snapping to the 0.3 in scale, in position, sorry. I can undo. The editor supports undo, multiple levels of undo, so that's very helpful. But we also see this gizmo, this 3-axis, 3 arrows gizmo that shows up on screen. They are red, green, and blue, and they represent the 3 axes that we can move objects in space. So for example, I can mouse over this red arrow, and when I hover on it, I can click on it and drag, and it's going to allow me to drag the camera on this axis only. So the axis, you can see on the little picture-in-picture, shows me a preview of what the camera sees as I am moving it around up and down. I can also go back to to the game view to get a bigger picture of what it looks like. And I can also select other objects and move them around this way. For example, this helmet that I see right here, you see it has also the same gizmo for transformation, so I can move it around in the different axes. I can even clip through the table, so be careful with that. You will also find that there is this little plane that I can mouse over here near the intersection of all these arrows. And this plane allows me to move in 2 axes at the same time, but ignore the third. So if I click on this one, it will move the object along the surface of these 2 axes, but not up and down. But I can do the same thing with the other axis and ignore the third axis. Undo to bring it back to where it was, and let's zoom out to get a better view. Then the next thing I'm going to show you is the rotate tool. You can see the gizmos change when the rotate tool is engaged on the selected object. That still is the helmet. And then what you can see here is that we have 3 different circles, also color-coded, to represent the different angles. Different axes I can rotate an object around, and then I can rotate this object around this axis, or this axis, or this axis. So that's how it works. Again, I can do it visually, and when I do this, all the values in the transform component are changing as well. So I can also change the values from here. This is another thing that you can do by using the editor to make these changes here. Finally, the last one is the scale transform tool. And you will get this gizmo that looks like, instead of arrows, are lines with a cube at the tip. And again, you can pull from each one of these modifiers, these controllers, to scale in different axes. But usually for scale, you want to scale uniformly across all different axes. So for that, there is this gray cube, little cube that you can click and drag to scale uniformly for on all different axes. Let me show you with an element right here. For example, this paint bucket. The scale tool is still selected, so whatever object I click on, I will get the gizmos for this. And this is how you can scale up and down elements to compose your scene any way you want. And finally, the last tool I want to show you is the rectangle tool. It's a rect tool. What you see is shows this modifier that allows me to scale an object by showing me a rectangle that is usually projected perpendicular to the point of view. So if I go along the plane of the ground, it's going to show standing upright, but if I look top down, it's going to show like that. This is usually helpful for some for transforming some sort of special cubes in 3D space, but it's originally created this tool for adjusting the position in space of UI elements. And I will show you this this tool later on. And finally, there is one more tool, a global tool. This tool allows you to have all the gizmos for the different types of transformations that you can apply on a transform, like position, rotation, and scale, all in one. So from here you get the same 3 arrows for the position displacement. We have the circles to control the rotation, and we have the gray square to control the scale, all without having to change anything, by just having this tool selected. So instead of having to go to move around, then I want to rotate, and then scale, I can have like this multi-tool selected and do all these type of transformations, even along 2 axes at the same time, along a surface, which is very helpful. Oh, there was one thing that I wanted to show you regarding scene navigation. So remember how you can orbit around and use the hand tool as well as the zoom in and out. So there's something that I found very useful, which is when you select an object and the object shows selected as so, you can press the F key, which is this option right here in the menu called frame selection. And what that does, it will like center the object in the scene view. So if I press F, that's what it does. Many people call this focus because it's using the F key, but it's called frame selection. And by right-clicking, I can look around, and then I can click on another object, for example this wood plank, and press F on it. And now it goes into the center of the screen. So by doing this combination of selecting frame selection and then orbiting around, you can move around the space by jumping from object to object. So I jump from this to this paint bucket, I look up, I see this light, I frame select that light, I zoom out, I go behind the wall, I frame select the wall, and you see how I can modify properties. This is the back of this wall. I can move it around. You see how it affects light. It's very interesting. And this is another way, more advanced, that once you get the hang of it, it's very helpful to navigate and move around and find the objects that you need easily. Another way to frame select is by double-clicking on an object. For example, I don't see it in the scene, so I can't click on it, but I can double-click on the hierarchy, the sun. And when I do that, the sun becomes selected and it's the center of the screen, and it's this point of rotation when I orbit around. I can zoom into it and get up close and then orbit around it or look around by right-clicking. So that is frame selection. So next we're going to recap what we learned so far, and I'm going to show you something new. So this is a cheat sheet I prepared for you to better illustrate the different ways of navigating around the scene that I showed you just now. I want to show you this fly-through mode. So the fly-through mode is a way to cruise through the scene instead of having to orbit around, pan, orbit, which is a bit more like stepping and walking around your scene. You can just fly through it. It feels a bit like a video game where you can walk around, but if you look up, you're starting to fly up. So in order to do this, you need to use the right click, the right mouse button, hold it down, and you will see the icon change to an eye-like icon with the keys icon that are laid out in the layout of WASD in your keyboard, which is a cue for you to use those buttons. By pressing WASD while holding down the right mouse button, you are able to fly around. If you press W, it's going to fly forward in the direction the camera is facing. So if you face upwards and press W, you're going to fly upwards. Then you can look down and press W and you're going to fly downwards. Also, you can move sideways by pressing A and D, or move backwards away from in reverse by pressing the S key. While flying, you can hold on to the Shift key, and that will give you a boost in speed. So if you want to move away, like outside from one building to another, you can easily momentarily speed up to get out of a particular area, and then release the button to go back to the normal speed. And whatever is the normal speed that you have is also something that you can set and define yourself. By holding down the right mouse button and using the scroll wheel, you'll see this piece of UI showing up on screen. It will show you the speed of movement for the fly through. So by default, I think it's set to 1, but you can make it very, very small so that you will be able to have more control. But you can change it on the fly. You can go very far away, And you can always press the F key to frame select and go back to up close to part of the scene that you were interested in visiting. Or if for any reason you fly away too far and you lost the scene and you can't find it anymore, you can also go to the hierarchy and select, for example, the paint bucket and double click on it, and it will frame select it. And wherever the scene camera was, it will snap back to the selected object that you just selected. It takes some time to get used to it, but once you get the hang out of it, it's going to be second nature, and it feels a bit like a game. These are the moving object tools that I showed you earlier in a graphic way. What's interesting is I show you the move, rotate, and scale. The rectangle selection, which is this one right here, as well as the global, the multi-tool. This is interesting to know that those tools in the editor are mapped to the keyboard, to the QWERTY keyboard keys. So the Q is a shortcut for the hand tool, the W is a shortcut for the move tool, the E is a shortcut for the rotate tool, R is for rotate, T is for rectangle, and Y is for the multi-tool. I usually keep my fingers on top of the W, E, and R so that I can easily change between move, rotate, and scale. And because I don't really use Q much, because I can use the mouse, the middle click button to get the shortcut for the hand tool. So I can show you what that looks like in the editor. So if you pay attention to the top here, when I hold down the W key, the selection of the move tool happens without me having to go and click on it. And then if I want to select rotate tool using the keyboard, I press on the E and the rotate tool is selected. And finally, if I press R, rotate tool is selected. So if I want to manipulate an object, I can click on this paint bucket, focus on it with F, maybe have a quick look around with the orbit tool, zoom out, maybe I'm too close for my comfort. So then I can change back to move tool, press E to rotate, press R to scale. And this is how I prefer to manipulate my objects in 3D space. But you have many options, so I just wanted to show you. So game objects and components. Remember how I said that in the hierarchy, all the elements that you see underneath the scene are called game objects. Game objects are made out of components. And by default, all game objects have a transform component. You can see right here, the directional light has a transform, and the light also, and the directional light has also a light component. But in case of other game objects, they might have different types of components. Remember, for example, the main camera. Oh, another thing that is important to know is the use of prefabs. So prefabs, Unity prefab system allows you to create, configure, and store a game object complete with all its components, property values, and child game object as a reusable asset. The prefab assets acts as a template from which you can create new prefab instances in the scene. Some common examples of the prefabs are environmental assets. For example, a certain type of tree used multiple times that is used multiple times around an area, or a non-player character, or NPCs. Imagine a robot that appears in your application in multiple opportunities, in different positions, across different areas. So they may differ in speed they move or the sound they make, but they can all be based off the same prefab, but they can have slight variations on each one of the instances. And finally, another example would be projectiles. Imagine in a game where you have a pirate ship cannon might instantiate a cannonball every time a cannonball prefab every time the cannon fires. For example, this workbench. It's actually part of a prefab already. called props. You can tell it's a prefab because in the hierarchy it shows as blue color. These are instances of a prefab. So this is helpful so that in case I want to bring another set of paint supplies, I can just drag it on the scene. 1, 2, and 3. And now I have what it looks like a lot of variety that I created very easily by just grouping them into a prefab and then managed to create multiple instances of the same prefab. And why this is helpful? Because imagine in the future I say, oh, the size for the buckets is wrong. So I could select the instance of my prefab that I have right here. And you can see this this button right here allows me to enter prefab mode. Prefab mode allows me to edit the contents of the prefab in isolation, but still within context. So I can see what are the elements around the scene. And for example, what I wanted to do was change the scale of the blue paint to be the bigger one, and the white paint can be the small one. So by doing this, I'm going to back out of this by selecting this option right here. And it's going to ask me, tells me that the prefab has been modified. Do you want to save it or discard the changes? So I'm going to click on save. When I click on save, if you see the other instances that I created earlier, including the one that was originally laid out in the scene, now the blue bucket is the big one and the white one is the small one, because that propagates across all instances. So using prefabs to plant around your scene is very helpful for this case. In case you want to modify one, in case you want to update the look of multiple instances of a prefab. This could be hundreds of trees or a stop sign in a city. You can change it once and it will be updated everywhere, or a traffic light. That's how you would use prefabs. So imagine I want to create a prefab out of this cube. So in order to do so, what I need to do is I select it in the hierarchy, and all I need to do is drag and drop it into the project window. And when I do that, you see what happens. In the scene, the cube seems like it didn't change. But if you look at the hierarchy, now it became blue and it has that icon that we discussed earlier, represents a prefab. And now we have a cube prefab showing in the project window. This means that now I can select this cube and drag and drop it into the scene, and it's going to bring up another instance of the cube. And now I have two instances of the same prefab. Another way I can bring another instance is simply by duplicating it in the hierarchy. If I duplicate an instance of a prefab, then it's the same as if I had dragged the cube from the project window into the scene view. And that is prefabs. Finally, we're getting to the fun part. We're going to create some interactivity in Unity. So here's an example of what we can make. It's a simple application that simulates dominoes falling using real-time physics. So let's create a new project for this. We're going to start from scratch. All right, for this, I'm going to bring my Unity Hub, and I'm going to start with a new project. I'm going to select the 3D core template and call it, and give it a name, my project, and create project. So you can see that it's creating the project folder for me, and it's opening the Unity editor. Okay, so I have my new project open on my screen right here. And the first thing we're going to do is look at what we have here. Our sample scene only contains the main camera, which we can see what the camera is looking at here, which is simply the skybox, the horizon with the simulated sky and ground, and the directional light. So what we need first is a plane that we can put our domino pieces on. So in order to do that, I'm going to right click on the sample scene, game object, and 3D object, and there's these different types of objects that I can create. I'm going to select plane. By doing that, I see a plane show up. It's positioned in 0 in the center of the scene. There's no rotation applied and scale is 1. This is good. So next thing, and then you can see on the bottom, the game view is showing that what the camera is seeing. So if I select the camera and orbit around, you can see where the camera is positioned. That's the point of view to render the plane in this way. And that's what we want to see. So we're going to modify the camera later to get a better angle for our domino application. So the next thing we need to do is to bring a domino in. So there's no dominoes as meshes, but we can bring a cube into the scene. So I'm going to bring a 3D object and select cube. Again, a cube pops up and it's in the center of the world where the plane was. But because this is placed in the center of the cube, you see how it's intersecting. So I'm going to bring it up to the position that it looks like it's sitting on the ground. And if I look at the position in the inspector, I moved it 0.5 units upwards in the y-axis. Okay, but this one still does not look like a domino. So how to fix that? So we can scale this. So I like to use the rectangle tool for this particular case because I can move it in 2 axes only. And then if I change my point of view, the rectangle changes to another place. To use another two angles. And then if you look at the scale that was resulting on the transform component, you see that it's actually 0.4 and 1.8 roughly for the cube. And that's how you can get a cube looking like a domino piece. You actually just scale it in the different axes. One thing to notice is that now we need to be able to have multiple dominoes, right? So in order to do that, I'm going to save this as a prefab. Well, I'm gonna give it a name, so you can select an object in the hierarchy, and in the inspector you can change the name right up here. For example, domino piece. Or you can also, in the hierarchy, click on it and press F2, and that will allow you to change the name. Or you can click on it again a second time once it's selected, and also that's a way to change the name. But by having that selected, I drag it from the hierarchy into the project window, and that turns it into a prefab. Again, you can see that the domino piece changes to blue, shows a new icon. The domino piece that we see in the scene doesn't really change visually, but now this is an instance of a prefab. And this allows me to place new pieces on the scene. So I can bring them from the project window into the plane and place them anywhere I want. Then I realized something, that maybe these domino pieces are a bit thick. So how do I make them smaller? Of course, I can just change the scale at something that I like 0.24, and this is good. But I want it to propagate to the prefab. So what I can do is right click on the scale and apply the prefab to the domino piece. And you see the other instance also changes scale. So let's place a few other items around. Another thing I can do to create different instances is duplicate an instance, I get a second instance. So if I right click on the hierarchy domino piece, there is a duplicate option, and there's a shortcut. With Control D, you can also duplicate. So there's a very, very convenient way of moving, pressing Control D to duplicate and moving around, and then I create another instance, and so on. So move, press Control D to duplicate, and move around the duplicated piece. And the same thing for the other side. Let's do one here, another one here, and another one here. And this is all good. So now one more thing, I think the light is shining a bit down too strongly on my pieces. So if I select the light and then go to the inspector, I can see the properties of the light. There's things that I can change, such as the intensity. I can make it very intense and it's going to blow up. So I can lower the intensity a little bit. I can change the color of the light. So for example, I can make it be a bit orange to try to simulate like a sunset. I can also change the angle of the light, and that will cause it to cast shadows, longer shadows, which might look nicer. So you can play around with the composition of your scene. Now I also want to change the camera position. So I'm going to click on the main camera, and I'm going to go to the scene view and press F to frame select the camera, and I'm going to use the controls to move it up and forward a bit, so I get a better view of the domino pieces from the game view, from the point of view of the main camera. And that's all very good. So then what I need to do now is to bring the marble. So in order to do that, I'm going to select the scene, right click on it, game object, 3D, and select the sphere option. When I select the sphere, you will see that a sphere is created in the center of the screen, again in the center of the world, which is again the origin where I place my plane and the initial domino piece. But I can select it and bring it upwards. This directional light, I can actually move it out of the way. Because it's directional, the position doesn't really matter. The direction of the light is what's important. So this is my marble that I want to play with and have it knock over all the domino pieces. So what I do is I bring it upwards, and then I think I'm all set. So what are the next steps to make this play out? I can see in the inspector that the sphere has a mesh renderer, like we saw before for a cube, so I can make it invisible. But it also has a sphere collider. So if I frame select and turn off the mesh renderer, you can see the green outline. This is the mesh collider. Sorry, this is a sphere collider, which is a representation of a sphere in the physics, for physics simulation. And the cubes that I turn into domino pieces, they also have a box collider. So if I turn off the mesh renderer, I can see that the outline representing the box collider is still showing. So this will work with physics. So I'm going to turn back on the visibility. So, but what happened to my sphere? I can't see it anymore. Oh, I'm going to select it from the hierarchy, click on it, and turn on the mesh renderer again, so I can see it and select it. So there is this button on top that's called play. This is to enter play mode. When you enter play mode, basically all the systems that rely on time start running, and physics is one of them. So physics simulations needs the variable time. So when I press play, I should see the ball falling down, but nothing is happening. Why? Because all we added was a sphere collider, but in order for this to simulate, to be affected by gravity, we need to add a rigid body component, and we can do so by clicking on add component here, and rigid body is the option that I can add. Once I add that, you can see that the sphere falls down, and it will like land on top of a domino piece. If I press again on play button, I exit play mode, and everything reverts back to the way it was before I started. So this is very helpful to iterate and play around with. So I can move the initial position of the sphere to be maybe in between these two tiles and try again. Play. Oh, but you will notice that when I added the rigid body component while I was in play mode, and by doing so, I unfortunately lost my changes once I exit play mode, because all the changes made in play mode are reverted back to the way they were right before you entered play mode. So if I want to add a rigid body component and want it to persist, what I need to do is I need to exit play mode, add my rigid body component, and then enter play mode again. Then this way it will persist. And you can see that sphere falls and gets stuck in between these two objects. But this is not what we want. We want the dominoes to fall over. So how do we do that? So the same way that we added a rigid body to the sphere, we need to add a rigid body to the domino pieces. So if I select one of the domino pieces this sphere is leaning against, for example, this one right here, I'm gonna see that it has a box collider, but there is no rigid body. So I can click Add Component and Rigid Body and see what happens. So now that particular piece that I added a rigid body on, now it gets affected by forces. So it still has a collider that determines the volume, but the rigid body allows it to take in forces and displace in space. So now we need to add rigid body to all the domino pieces. So how do we do that? We can go one by one and add all rigid bodies, but remember, these are instances of a prefab. So what I can do is, by having only one domino piece selected, I can just enter prefab mode, and then in the inspector I can add one rigid body. Then going out of the domino piece prefab mode is going to ask me to save it. And now if I select other instances and look at the inspector, I'm going to see that all the different instances, they have the rigid body because I added it to the prefab. And all the instances reflect the change. So having done that, when I press play to enter play mode, the ball falls and pushes away all the dominoes, which in turn is a domino effect, so they all fall down. So this physics engine that Unity has is a very precise, very fast, real-time physics engine, originally developed for games, but it can be used for other types of simulation. Like you can have many types of colliders and physics systems involved in your applications that you want to develop. So this is a very simple approach. All I did was create like a basic shape, like a sphere, the cube, and add a rigid body to it, and the simulation, all the calculations for the physics and where things are supposed to be is taken care of by the physics engine built into Unity. So finally, the last thing we need to do is to add interactivity, meaning that when this application runs in the target platform, imagine that it will run on a mobile device. All these options that I see around in the editor are not going to be there. All I will be able to see is this, what the main camera sees. So in order to interact with this, I need to add some sort of like buttons or a menu on screen. So in order to do that, I'm going back to the scene in the hierarchy view, and I'm going to right click anywhere. Let me get myself out of the way. And you will find, instead of a 3D object where we were before to create the cube and the sphere, there's this option called UI. And for UI, there's many different things that we can add, like text, image, and the one I'm interested in today is button. So I'm going to select button, and you will see something show up here. Next to my dominoes, you're gonna find like a giant button appears here. Why is this? Because the UI actually works in world space. Even though it's meant to be rendered on screen, it appears as another object like the dominoes, only that is rendered by another process. And if you see on the game view right here, you will find that the button appeared on the lower left-hand side corner. Now I have a button on the screen. So let me show you now how editing this button. So the way I would do that is, and the same navigation mechanics apply. I can click on the button, press F, I can orbit around the button, I can zoom in and out, but usually for user interface you want the UI to be laid out on a flat surface. So for that, there's this button right here that says 2D. And what it does, it gives me an orthographic projection of the scene view so that I can easily see the button and move it around. And also, this is, you can tell that the rect tool is selected, which originally was created to handle UI. I was using it earlier to modify the scale of 3D objects, but in my case, this is the use case for this tool, to modify a rectangle for UI. Also, I can zoom out to see this white outline that represents the screen. And some of the good things I can do with this user interface is I can look at the inspector and see that this one doesn't have a normal transform. This one is called the rect transform because it's a piece of UI. It not only has position, rotation, and scale, but also like information about which corner to be anchored to. So that if we have a display that is square, or if we have a display that is like widescreen, it knows that it needs to be positioned itself relative to a particular corner or an anchor point. And there's a lot of alignment tools that you can use here. Clicking on this, and you can modify by holding on to the Alt that also sets the pivot, or Shift. Shift sets the pivot, and if I hold down on Alt as well, it also sets the position. So I'm going to select Alt and Shift and click on the top right corner, and you see how my button is aligned to the corner of the screen. And from here I can, from here I can zoom out a little bit and maybe move the button away from the corner to give it some space. I'm looking at the game view to make sure that it's in the place I want it. And this is looking good. That's what I wanted. So the next thing I need to do is change the name. I change the label inside the button. By default, the button has a button label. So let's go back to the hierarchy, and you will find that the button first lives inside this canvas space, which is this rectangle that represents the screen. My button component, my button object is there and is represented by another rectangle nested inside the canvas. But you can see that I can still expand this further. So when I expand this, I will find a text game object inside. And this text game object, if I look at the inspector, you will see that it has text-related components. So we have a canvas renderer instead of a mesh renderer like the 3D objects. And we have a text component that allows me to change the properties of this text element. And you can see that the text property, it's button. And this is where I can change the label by selecting the text and typing something else. For example, drop marble. And that's how I change the text. You can see it changing in the button as I type. Real time as well. You can change the font. You can change the font style. Let's make it bold. And the font size, I can make it a bit bigger so that it's visible. And that's how I can customize my button label and the font. Then if I enter play mode, this button is actually interactive. You see that it changes color when I click on it. I'm pressing on it. But now what I want to do is I want to make it so that when I press this button, the marble will drop and not before. So in order to do that, what I'm going to do is I'm going to select the sphere, our marble. I'm going to exit out of this 2D mode so that I go into perspective. Press F to frame select my marble, just to get a better view because I want to see it in context. And I want to show you in the inspector right here. The rigid body component has this property called use gravity. So use gravity is selected, meaning that when we enter play mode, the gravity force will be applied on this rigid body, pushing the object downwards. So, but if I uncheck it, it means that there's no gravity applied on the sphere. So we can see what this looks like if I press play. So now the application is in play mode, but nothing is happening. The sphere is not moving. So if I go back to the rigid body and check the use gravity box, you can see that then it will start being affected by gravity and fall down. So now what I need to figure out is how to make this flag use gravity turn on the moment I press on drop marble button. So in order to do that, let's exit play mode. I'm going to go back to the button in my hierarchy right here. Select the button and look at the inspector. And you will find that there are some cosmetic options for the button component, like the colors it will have when you press on it. You saw it becoming gray. That's why, because there's a press color defined here. You can customize and change the colors that you want. But what I'm interested in is this area right here called onClick. This is a Unity event exposed here in the inspector that allows me to add an item, an element to this list. By using this plus button right here, I can add to the list. And by adding one element to the list, you see what happens. I can define a target object. And what I want to define in my case is the sphere. So there's this way to set the target. I can find it in the hierarchy. My sphere is right here. And I can drag and drop it into the object field. And right after I do that, you will find in this drop-down menu right here that I can see all the components that are attached to this target game object, the sphere. And I'm very interested in the rigid body game object. And you will see that here all the properties and the types of properties that I can get access to. The one property that I am interested in is this one, use gravity. So I can find the property that I want to modify, and then this checkbox shows up because this use gravity property is a Boolean. It can be either true or false. So this checkbox represents true or false. If it's checked, it represents true, and if it's false, if it's unchecked, represents false. So I'm going to have my sphere rigid body use gravity property originally set to false, so that it doesn't fall when it enters play mode. So by defining that when this button is clicked, it's going to modify the use gravity property on the rigid body of the sphere to true. And that is how I can connect my action of clicking the button to turning on the use gravity property on the sphere. And that should be it. If now we enter play mode, nothing is happening. And then if I come to the game view and press on the button, I can see how now that I created the interactive action of enabling the use gravity flag on that. And that's how you add interactivity in Unity. This is an approach of not using scripting, but actually there's Unity supports C# scripts. That is a very mature language that has a lot of documentation everywhere that it takes some time to learn. So if you're interested in learning scripting, there will be more webinars regarding scripting. And there's also Unity also supports visual scripting. So if you don't want to deal with code and type code, there's also a way to visually add nodes with a plugin called Bolt that is free to use if you have Unity, which is another option to add interactivity to your projects. And that's how we created the project with interactivity from scratch. Adding physics, adding UI, and hooking up the UI to modify some properties of our game object components. Okay, let's minimize this. And this is what we achieved. Next step. Next step is your Unity journey. There you go. From here, your Unity journey begins. I hope you are excited because picking up Unity is actually a lot of fun. As a beginner, the best place to start is through our Learn platform on learn.unity.com. Here you can find carefully crafted step-by-step courses for absolute beginners, as well as tutorials covering multiple topics. If you are an intermediate or advanced user, there's always something new to learn. You can find tutorials targeting specific industries as well. For example, AEC, automotive, films, or games. And you can also jump into some cool projects through the Unity Hub, where you can mod and tinker with existing projects and make them your own. You can see here on screen, when you start a new project, there's a way to filter them. And the ones categorized as learning, they also show here are the Lego microgame, 2D platforming microgame, karting microgame, and FPS microgame. The interesting thing about these projects that you can import from the hub is when you start them, they have a built-in tutorials built into the editor, so you can follow along the steps and learn how to develop a game, as if somebody was teaching you sitting next to you. It's a very good learning experience, and it's built into Unity. So please have it try, give it a go. To me, using Unity, it's a very fulfilling experience to be able to bring ideas to life, to create something positive and meaningful that brings joy to people in the form of entertainment or improves their life by using tools made with Unity in all kinds of industries. I hope you all learned something useful during this webinar. Thank you so much for tuning in, and I hope you had a great time exploring Unity for the first time. If you have any questions, the team and I will be more than happy to help them answer. And now we're open for questions.
Thanks, Hector. Awesome presentation. I know that these take a very long time to put together. So I really appreciate that today. And your very first one for Unity. I think you did a great job. Hope everyone agrees. So just to recap on our monthly schedule for February, we have a session on Art Engine next week, followed by CAD and mesh data with Pixies, and that is more on the industrial application of Unity, and introduction to editor scripting later in the month. Now, some very exciting news. If you've joined us today and you're thinking, I want to create a project from scratch, a game, we have a great new series coming up later in the year to give you a bit of a preview on. We're doing 3 different series over the coming months. One will be building a 2D game in 3 parts. That will be starting in April. We'll be doing a 5-part series on building an arcade racer, and an 8-part series on building a third-person shooter. So we think that this might be an interesting approach to go from start to finish in building one of these projects based upon the beginner modules that we do every week on a Friday. And the survey link for one of our lucky attendees today will win a Unity swag pack. It's only for registered attendees via Zoom. And if you joined us on other social media platforms, we gave you the QR code at the beginning of this webinar. Please take a look at that link now, and over to more questions if you want to answer them live, Hector.
Yes, I'm here. I'm going to look at the questions and answers window and see if there's anyone with any questions. Please put them in. Okay, so there's a question about augmented reality. It says, we're working on AR content development for school textbooks. Can you guide us? So I think the best way for you would be to get familiar with augmented reality development in Unity, which you can find tutorials and starting projects by using the Unity Hub. And once you get a sense of that, also there's more information that you can find in the Learn platform. at learn.unity.com, where you can get familiar with the process of building applications, and so that you can, in turn, produce textbooks and teach other people. Okay. How to book the next webinar. I think you will receive an email invitation, and following the links there, you can go to the registration page and add your details, so you can be informed. I think if there's any more information on that you want to share, I think that's the way it works.
Yeah, some of our attendees get an email at the beginning of the month with all of the webinars for the month. The trick is you need to register for each of them separately. And if you are not on that email distribution list, you can always join our social media pages. There is a link in the chat. Just if you scroll up a little bit, I placed it there not long ago, and we usually post those on the Friday for the following week. And each week we have new content, we'll post it there.
All right. Let me see if there's any more questions on the chat. So there's somebody asking about attending seminars outside of the time we go live. Well, yes, the seminars will be recorded and are being recorded and will be shared. So don't worry if you can't join at the time that we have them scheduled for. You will only miss out on asking questions like right now, but I think you will still benefit from accessing the content.
And of course, the chance to win a prize pack.
Correct, yeah. Let's see if there's any more questions.
There's been a few questions.
There's a question here.
About the pack, yeah, and we draw this after the webinar, so you have to be registered. And there was a draw process that takes place about 30 minutes after the webinar, and the winner will be notified by email to provide their address for us to send it.
Okay, so there's a question about tutorials on the Racer and Shooter. So where these tutorials can be downloaded from. So there is this Learn project that you can find in the Unity Hub. When you start a new project, you can click on the Learn category to filter out these projects. And here's you can find these projects templates and start a new project and follow along the tutorial that is built into the editor. Let's see if there's any more questions. Okay, how can I design UI that fits all mobile devices? And this is a topic I have experience with, having working on. I have worked on UI for multiple and different devices like mobile and PC, and Unity system has a very robust system to support different aspect ratios and resolutions. What you want to focus on is the Canvas game object that includes different components, including the Canvas scaler. And there's different ways to have the UI scale. So it can be pixel perfect, it can be relative to the width of the screen, to the height of the screen, regardless of the resolution, to have the UI work any way you want. You can also have exceptions be done depending on particular aspect ratios in very rare cases or extremes. But what you want to focus on is learning about the Canvas scaler and all the different properties that it exposes. There's also a very helpful thing that you can do in Unity, which is the game view. You can preset a fixed resolution for your target device, and you can preview what it would look like on that device without having to build a project and run it on hardware. So you can preview the UI on the game window. There's a question about how to start a first-person shooter game. Please look at the Unity Hub. There's a first-person shooter sample project right there. Is there an application? Will be like and the file size for the application on Android will be heavy or like a lot of a large number. That depends on the systems that you add to your project, and Unity is smart in the sense that if there's any components that you don't use, they will be stripped out of the final build. So if your project, for example, doesn't use physics at all, the physics components and all the code that makes use of the physics simulation will not be added. Same thing with audio and many of the other solutions and packages that Unity supports. Let me see if there's any more. There's a lot of questions about augmented reality, very specific or technical, I think. Do we have time for more questions?
Maybe a couple of the, if there's any particular key ones that you see, I'll just answer while you're scrolling through that. I'll just answer a couple of general questions. There's still some questions on the eligibility of the prize pack. If you registered and you've joined us on Zoom, you will need to complete the survey form and provide your email address at the bottom to be eligible to go into the draw. And there's some sessions coming up on AR and VR. We did some last year as well. There is a new South APAC webinar page. We have posted some of the key content from last year, and Sarah, who is on the call, will probably be giving a plug to that in the email that goes out next week, so you can watch it on demand. With regards to the third-person shooter and car racing game series, whilst those assets are there that online that Hector has mentioned, we will be doing a series on these over the coming months before the halfway point in the year. We'll be covering these 3 series. Is there any other questions there that you want to address? I know there's quite a lot of questions, folks. We may not be able to answer them all today.
Yeah, I'm actually trying to still find out one that I can answer right now. Some licensing questions, some seminar questions. Oh, okay, here's one. How does collaboration among colleagues work when working on the same project using Unity? So we have a version control service as part of our operate branch of services that we offer, and that is built into Unity. So when you start a project and you want to work remotely with other person, you have the ability to create a repository on the cloud, and both of you can synchronize the project. And this extends not just for 2 people, multiple people can be working at the same time. And this is a way that you can collaborate. When we first start, we usually work by ourselves. And sometimes we send copies of the entire project that we created on our computer. But the proper way, the professional way of doing this is by having a version control on the cloud where people can synchronize and get all the changes at the same time.
Okay, we might wrap that up for today. I know there's still a few questions there, but I think that will keep coming through. We're running a little overtime today. If there's something you really need an answer to, we have an answer for you today. Please refer to the email in your original invitation. There's an email address there, and as well as Hector's that he just gave earlier. And with that, we look forward to catching you next week and over every single week throughout this year. Today was the first of the 2022 series. It's been great having you all on board, and we look forward to sharing more and delivering more content on how to make you all amazing Unity creators. Thank you so much. Goodbye, everybody, and stay safe.